We have the differential equation x squared minus y squared times y prime is equal to 2x times y. Okay, the first thing I'm going to do is make a substitution. I'm going to let y equal v times x. And so the derivative of y with respect to x will be the derivative of v with respect to x times x plus v times the derivative of x with respect to x. So you can simplify it as x times v prime plus v. So for every y, so this y and this y, I'm going to replace it with v times x. And y prime is going to be replaced by x times dv over dx plus v. Now, I skipped a step here, but basically we had x squared minus v squared times x squared. And I pulled out an x squared from this to get x squared times a quantity 1 minus v squared. And I left this in the parentheses alone. And then here we just do x times x to get x squared. So that's just 2x squared times v. Now I divided both sides by x squared and 1 minus v squared. So it's x squared times 1 minus v squared from both sides. So I'm left with x times dv over dx plus v is equal to 2v over 1 minus v squared. I subtract both sides by v. And at this point, this is a separable differential equation. So this whole right side here represents, function of v. So that's going to be divided. So in other words, it's going to move down here. And then the x and the dx are going to move to the right. So we're going to multiply by dx and divide by x to get to this. Okay, now I'm going to get a common denominator of 1 minus v squared, subtract. Again, the details are missing here, but when you do that, you get this fraction in the denominator. And whenever you have 1 over a fraction, that's just going to be the reciprocal of the fraction. So basically, you're going to have the denominator of that fraction over the numerator. Okay, so that's kind of what happens here. The denominator 1 minus v squared becomes the numerator, then the v cubed plus v becomes the denominator. Okay. Now I'm going to divide every single term here by v squared. So 1 divided by v squared will be v to the negative 2. Then v squared over v squared is just 1. V cubed divided by v squared is v. And then v divided by v squared is v to the negative 1 power. So make sure to divide every single term here on the left by v squared. Now I can integrate, but in order to integrate, I'm going to let u equal v plus v to the negative 1 power, and so the derivative would just be 1 minus v to the negative 2nd power dv. So basically, the derivative of the bottom is the top, except for the minus sign. So what we have to do is basically multiply both sides by negative 1. And this is a u. This is supposed to be du here. So we have negative du over u. And then the right side is equal to ln of absolute value of x plus c. Integrating this becomes negative ln of absolute value of u. Now we just need to undo the natural logs. And also, I did substitute u equals v plus v to the negative 1 power in this step as well. So we just need to do e to both sides. Now, well, I guess before we do that, actually, what I did here was I combined the v plus inverse of v into v squared plus 1 over v. So basically, I just rewrote this as v plus 1 over v, and then got a common denominator, so that became v squared plus 1 over v. And then finally, I did e to both powers, or both sides. And because this is a negative, this negative is the exponent of whatever is inside there. So really, you're just taking the reciprocal of whatever's inside the absolute value. So that's v over v squared plus 1. And on the right side, you can rewrite this as e to ln absolute value of x times e to the c. This is just a constant I called it c, and this is just x. So that's why we get c times x there. Now I distributed both sides of v squared plus 1, so multiply that both sides. And then I brought the cxv squared and the cx to the left by subtracting, divided by negative cx to get v squared plus 1 minus v over cx. And the whole goal here is to complete the square, so I subtracted both sides by 1 and then complete the square. So the way to complete the square is take negative v over cx divided by 2 and square it. So if I divide it by 2, I get negative v over 2cx. Square that, I get v squared over 4 times c squared times x, x squared. So that's what I added here. So you want whatever you do on one side, you do the other. So this factors nicely to v minus 1 over 2cx squared. Now I can take the square root of both sides. And when I take the square root, you want to include both the positive and the negative. So then I can solve for v by itself. But recall v was y times x, and I want to solve for y. So what I have to do is just divide both sides by x. And so this is my solution.